Nice crowd tonight. I'd like to let you all know that this was, I guess, voted, rated, ranked the most popular event in New York City tonight. So, round of applause to everyone for showing up. And my mouse doesn't work.
Really?
I think we need a few more people.
Did you hit the switch on that?
There we go. Okay. That reminds me. It's a good time to turn off your cell phone. Okay. So just what we're going to talk about tonight is, everyone get pizza? Really good pizza in the back, sodas. I'm going to talk your ear off a little bit about who we are and what we do, not long. And then Elliot Cordell, principal consultant, is going to talk about NoSQL technologies, where they are, what they do. And then Mike O'Brien is going to do a real a use case of a specific NoSQL database called MongoDB. Let's see if I can do this. Okay. And then we'll hang around for a while and talk some more and get to know each other. So the BDW, the Big Data Warehouse, or the Big Data Warehouse, we made this group because we've been dealing with data warehousing for, I'm going to say about 17 years now, a very long time. And using traditional methods for the most part, your Oracle, your SQL Server, DB2, mainframe, client server, what have you. And it's just been getting bigger and bigger and bigger and bigger. And you know, as all the stats say, that 90% of all of the data in the world was created in the past 2 years. So it's really getting to a point where even our best practices for building traditional data warehouses are starting to lack in scalability and flexibility. And also the type of data that we're dealing with now is completely different. We're used to very rigid structures of transaction systems bringing data into data warehouses, and that's just not the case anymore. We're getting data from being created by humans, by machines, all different formats, all different layouts, internal data, external data. So we created this group to just start talking about the transition of getting data from into, or the transition from traditional data warehousing to big data warehousing. This is our third event so far. First event we talked about relevance engines and machine learning, some of the new techniques that you can do in the big data paradigm that's more difficult in the SQL-based paradigm. And then last time we talked about Hive and Pig, some of the languages that are very different when you're dealing with big data. This time we're going to talk about NoSQL. NoSQL doesn't mean that it's not SQL. I mean, it's not only SQL databases. So we are, and we do want to make this as interactive as possible. Feel free to ask questions, share your own experiences, and if you do want to present some of your own work, feel free to reach out to me, joe@casertaconcepts.com, and we can have you come up here and show some of your work. So we do big data analytics, data warehousing, business intelligence, and then we help people do the transition from an ecosystem and infrastructure level, getting your data from your traditional, conventional data warehouse environment into a big data warehouse environment. Across all different verticals, really doesn't matter. I think just because we're in New York City, we do a lot of financial services, a lot of healthcare, a lot of insurance mostly, and lately a lot of higher ed. I wrote the book, The Data Warehouse ETL Toolkit, industry bestseller. Some of our clients, no presentation would be complete without a page of logos. I don't know what to say here. And then some of our expertise. We do strategic roadmaps for getting you from where you are to where you need to be. Do that as separate engagements. And then we do the actual implementations of all of the technologies. We're partnered with most of the logos here. We're partnered with Cloudera, we're partnered with Datamere, partnered with LucidWorks. Actually, there's some missing here. PowerXL, Talon. And we are hiring. We are actually at this very moment looking for people with deep expertise in Cassandra or deep expertise in Storm, or if you have both, it's a slam dunk. You can start tomorrow. But if any of these words excite you, if you're really into data, then feel free to reach out. You can reach out to me directly, Joe, Caserta Concepts, or generic jobs to Caserta Concepts. That's me. Dana Canavan, where's Dana? Dana in the back. She's in charge of sales. If you're interested in engaging us, that's the person to talk to. And then we have Elliot, who's going to speak next. We also have Indu in the stripes back there. She's one of our tech leads. And Tatiana, say hi. She's our admin. Admin day coming soon. Gotta remember Tatiana. And I think that is, oh, okay. So now, why are we talking about NoSQL? What's the big deal? So this is the old school, right? This is the old days. This is anyone with gray hair remembers this, right? We have ERP systems, we have transaction systems, finance systems, legacy systems, trying to get data out of them for analysis, right? Great for getting data in, terrible for getting data out, and especially terrible for drilling across, figuring out the finance and the legacy systems and ERP systems, how it's all correlated and how to crosswalk across systems. Terrible, right? So what do? We write a whole bunch of ETL, we do some data modeling, we write a very traditional data warehouse, and then we put a BI tool on top of it, and we enable users to do ad hoc reports across any spectrum of the entire enterprise. Been doing this for a very long time. And it's successful for the most part. But then we start seeing stuff like this come in. So now we're getting unstructured data, large volumes of data, web data, tweets, and now we want to try to start correlating that to our transactions, and it becomes very, very, very difficult. Right? Parsing this stuff the old-fashioned way is virtually impossible. So what do? So we bring it all into Hadoop, right? Hadoop. We build a cluster, we bring it all in, and then we start mining it in place. Right? And we start using Mahal to build some machine learning algorithms and start mining the data. We're doing a lot of the manipulation with Hive and Pig, and it scales linearly. So scalability is not an issue as long as you're a techie. Getting data out of it is not an issue. But one thing that's really not good about this is that it's all batch oriented, right? So you write some code, it generates some MapReduce jobs, and then you get the data back eventually, and the latency is too big, it can't be tolerated compared to traditional BI. So what do? So what's happening is that this new concept of NoSQL databases. So these NoSQL databases are low latency, right, big data solutions. So what we're seeing now is that the big data BI tools are able to attach directly to the big data cluster. Right? So we have tools like Akunu and Datamere who don't need a traditional data warehouse and don't need traditional BI. So right now, a lot of our clients, all of this is coexisting. But once we have all of the data and all of the ETL taking data out of the legacy systems, out of the warehouse, out of all of these unstructured sources, putting it into the big data cluster, and we can do low latency analytics directly. So now we have to put our crystal ball, take our crystal ball out and say, will the traditional paths still be needed in the future? It's hard to say. I'm not going to say yes or no. It's hard to say, but it's questionable. As the technologies down here mature and get better at what they do, and start becoming more user-friendly, because a lot of this stuff is still very code-intensive. As the products start arriving where the non-technical could start doing analysis here, it's going to become very, very, very questionable on whether you need the top row. So with that, oops, wrong button. I made a mess. We are going to introduce Elie Cordot, and he's going to dive into showing you exactly what we mean by NoSQL, some actual code you're going to put up there, and some diagrams of the different types of NoSQL databases. So there you go, Elie.
All right. See if my trusty mouse will work. So I'm Elie Cordot, Principal Consultant at Caserta Concepts. And today we're going to do an intro to NoSQL. Before I get started, how many people are using a NoSQL solution in an organization? Well, obviously you, man. It's a MongoDB guy. So, it should be take you through some basics and try to do an overview, and hopefully you guys enjoy it. And oh, Joe, what did I do? You'll be my mouse?
I'll be your mouse.
I'll give you the thumbs.
Do you want to use it?
I've done worse. No, we're okay.
Thanks. All right, so for SQL lovers out there, you know who you are. I put up that little heartbroken SQL thing. I think it's a little more illustrative than that NoSQL is the line through it. I think that's kind of harsh, you know. So I think the first thing that we want to say is, relational databases have their place. You know, they're general purpose. We're all very familiar with them. I'm sure a lot of you guys are. And, they've been around a long time, so they have a very rich kind of usage and query syntax and tools we can use to work with data. So, to say that they're going away and NoSQL will replace them like right now is probably not a fair statement. However, with the recent crop, there's some very interesting alternatives for analytic databases. You have listed here columnar, key value, document, and graph. There are others, some fairly old, such as object and XML, and there's a pretty rich history of NoSQL as well. But for now, we're really going to focus on these kind of new and popular types. And also focusing on the NoSQL word. As Joe said, it's really not only SQL, because many of these systems have a SQL-like interface, such as Cassandra has CLI, and it's SQL. It's very, very familiar. So I guess the question is, why are we doing this? The relational database is pretty good, right? So I think we'd start out with some functional reasons that we would, think about using alternate ways of storing data. Sparse data and data with a lot of variation is a very good use case for a NoSQL store. If you have, if you think about like in a social networking site, how much of a profile is actually complete? LinkedIn tells me my profile is not complete all day. In the relational world, you couldn't model that very effectively, but a document database, for instance, doesn't mind if you leave out columns or you create new attributes. It's schemaless, and it's pretty happy being that way. And a very special type of NoSQL, which is a little different than the others, is the graph. And it's a funny thing, but relational databases really aren't that good at exposing relationships or the relationship between its contents, its rows, and the different entities. So it's a very interesting use case for graph databases as well. So Another good reason we should talk about this is performance. As you know, relational databases like to grow by getting bigger servers. So you just keep getting bigger and bigger servers, and eventually you've got the biggest one, and then you have to scratch your head and open your wallet. So that's a big thing. And another thing is that they have a lot of overhead and a lot of features that we might not necessarily need depending on our use case. Now, getting back to scaling, a lot of people have dealt with this by doing federation or sharding manually, and it's really not a very happy thing to do in a relational database. Most NoSQL stores, they support it naturally. They're made to be distributed. They're made to auto-shard. So it really makes it quite easy to have a very large system and allow your system to grow horizontally. Little side note, getting back to our graph database friend, their model doesn't really support splitting up, and kind of distributing, but there's a few vendors that have overcome this obstacle. Next. Here's another one, more on the app dev side. They call it object impedance mismatch, where the way you've modeled your data relationally is in entities and relationships between entities, kind of philosophically the way that things work. And in the end, you end up, taking the data apart and putting it back together routinely just to answer questions and insert new data. So, it's not very efficient. It's very flexible because you can query the data in very general ways, very specific. You have a lot of flexibility, but it requires a lot of joins, and when you have to insert stuff, you have to rigidly adhere to the structure of your tables and do multiple inserts, and it's just there's other ways of doing it. But as we're going to see in a minute, it's not all rosy. NoSQL databases do have some limitations. They have fairly simple query languages, and such as joins, aggregation. A lot of them don't support secondary indexes. So if you want to query on a specific field, it can be pretty difficult. And it's not because they aren't designed well, but it's really fit for purpose. They were designed to be high performance. So the idea of doing all this calculation at the time of query just didn't make sense. It makes sense to do it ahead of time and write simpler queries and have less cost in the database. So really the concept is the data is stored as it's used, tuned to the query, rather than modeled around entities. So for that reason, they decided that a sophisticated query language really isn't necessary in all cases. So now there's a question that you've probably all Googled a few times. So what about replacing our relational data warehouse with NoSQL? Just NoSQL alone. I think the answer is you probably could, but you'd have a lot of limitations. A lot of the things that I just mentioned. They're not as flexible as relational databases. If there's new questions that you really haven't thought up or modeled your data around, in a relational database you'd probably struggle and bring in new tables and perform joins, and it might take a little longer. NoSQL, it's a little more difficult. Everything's tuned around use. Another thing is lack of joins requires denormalization. So if you think about a fact and you want to query by certain attributes or group by certain attributes, you have to think about that ahead of time and denormalize. A very common design paradigm is the idea of materialized views, where you re-aggregate and kind of create different views of the same data, because write cost is relatively low and storage is cheap. You just keep multiple versions of the data, but that has its drawbacks to data anomaly, as well as you're doing a lot of materialization. You can't essentially anticipate every way that the data is going to be used and pre-compute it. You probably be a little self-defeating. So really where we found the sweet spot, and I'll talk about a use case with you guys, is really like high volume, low latency analytics. Queries are largely known ahead of time. The volume is very, very high, the tolerated latency is very low, and you can kind of do that modeling up front as you ingest the data. Also, the different platforms have different features which have been developed over time, such as Cassandra's counter functions, which can be helpful in pre-computing aggregates. And as this graph kind of shows you, and the curve is kind of arbitrary. Just wanted to prove that it wasn't like linear. I don't really know what it is, but as volume goes up, query flexibility goes down a little bit, and you make the paradigm shift of relational database to NoSQL. So NoSQL can handle a lot of volume, but your query flexibility will go down a little bit, your ad hoc query capabilities. So the first platform, type of NoSQL we're going to talk about is columnar, and this is one that we're actually actively involved in a project on. Some popular platforms that you might have heard of are Cassandra and HBase. The column family is kind of the concept that is equal to a table in a relational database system. And the primary unit of storage is a column. So there's really a very familiar look to one particular way of modeling the data, which is the skinny row, which if you were going to have a user profile table, it would probably look just like this. It would look, you'd have some sort of key, in this case it's user, and you'd have some data. The main difference here is that columns are optional, and you can have them blank, and it doesn't store it. It doesn't store a null value, it doesn't keep a -1 or an NA. The column just doesn't exist. The attribute value, the tuple doesn't exist in the database. So that one's pretty familiar, pretty common. You'll see some denormalization in rows such as this, but more or less it looks like a relational table. The one that's a little weird is the idea of a wide row, and this is fairly alien. Because in a relational world, you get into trouble if you had a row which was billions of columns wide. Probably something you'd get yelled at about. I don't think actually any relational databases would allow you to do that. But it's used in time series, relationship secondary indexes. In the example here, you can see that we've got kind of like a denormalized horizontal row of purchases by user. And the thing that's very interesting is that the column name is actually the key. So these are all different columns. They're sorted ascending. So if I wanted to do a range scan and find out what people are buying from January to February of 2013, it would be a very, very efficient query. As well as looking up the purchase history for Bobby would be very, very efficient. So, it's one that you got to play around with in your head a little bit to get a handle on, but, it's one of the modeling techniques. So now we have our document DB, and platforms are MongoDB and CouchDB. Pretty popular, there's many others. In this case, collections are equivalent to a table in relational database systems. This one's even a little looser definition than the column family and columnar, because really you're saying is that I'm storing a bunch of documents and they're related. They're about the same thing. Here really that kind of volatility in structure really comes out. For instance, Bobby has a state in the channel. Susie doesn't have a state, and she has these preferred categories, which are kind of like child records within the structure of the document. And document databases generally don't mind if you create new fields. It's pretty fluid. We could create a field called, shoe size, and only have it for a few users, and that would be perfectly fine. Yeah. Lastly, we have one which is much unlike the others, which is the idea of a graph database. So in this database, relationships are front and center. The relationships themselves are really viewed as like entities or properties. It has a pretty rich query language devoted to traversing the graph and drawing data out of the graph based on relationships. So we've got a bunch of people and their friends, and they have bidirectional relationships. In this case, only outgoing with Susie's. Bobby likes Susie's profile. We have products, where we have purchase events with properties, channels, and dates, as well as likes on products. And this structure allows you to run a lot of query like finding all Frank's relationships and levels deep, or stopping somewhere maybe 2 levels deep. Finding all products related to Jillian, finding the shortest path from Frank to Susie. And one of the very interesting things to use this for, other than like optimization problems like paths and networks, is recommendations. There's a pretty rich set of functions that go with this in terms of collaborative filtering, so you can generate recommendations out of graph databases pretty well. So based on Susie liking chainsaws and hair bows, we might infer that, also because Susie and Jillian are friends, that she might want a chainsaw. So that's what a graph database looks like on a high level. Now we're going to talk about a project that we're actually working on right now, and it's a pretty challenging one. So it's a high volume sensor use case. So we're ingesting a enormous amount of data and being asked to do something with it. So essentially, the data volume is pretty massive. We need to ingest 6 to 12 billion records per day. And I say records are really messages, so you might even normalize out to a little bit more, which is 140K records per second at peak load. So it's a pretty challenging ingestion problem, let alone being able to calculate any analytics or draw any conclusions from this data. It's just literally streaming in at an enormous rate. But we're actually being asked to do something with it. One, it's mission critical data, so it has to be stored to disk, highly availability. Okay. We need disaster recovery for this. We need it to be persistent. And then the doing something with it. We have to do predefined aggregates and event monitoring, like identifying bad patterns in the data in near real time. So I think our current goal is being able to include events in an aggregate and find malicious event activity within a couple seconds of ingestion. And finally, we have to provide more robust ad hoc query capability on the back end later on. And higher latency is allowed in that case. So here's the top secret design. It actually looks pretty simple, right? So here we have a large box, a large amount of sensor data coming in. And we're ingesting it into Kafka, which is like a high-performance, very reliable messaging system. So that handles the ingestion point, and then we've got to do something with it. So we're using a real-time big data ETL tool called Storm, which essentially allows you to perform a lot of the operations you guys are familiar with in ETL in real time, rather than being a batch or a multi-batch. It has this concept of a spout or a faucet. You take the data in real time, run it through a typography, and you can emit it somewhere. And it's just continuous. Things come in, and it processes them and spits them out. And that's where the NoSQL store comes in. So not only are we ingesting 12 billion records per day, but we are also doing stuff with it. So we've got atomic data aggregates and events that we're writing out to Cassandra in near real time. And then once we have it there, we can do low latency queries through a custom analytic dashboard. And in batch, we can offload the data to Hadoop, where they can use Pig and Hive and maybe even Datameer to do more ad hoc analysis with the data. So a parting thought here, a guy wrote a very good book on NoSQL and a lot of good blog material. The idea is polyglot persistence, and you can read it, but really what he's saying is, the right tool for the right job, and don't be afraid to involve different technologies and different analytic stores, if they fit the business case well. So that's it.
One more.
Oh, we have the component. So very similar to, that was my talking point. All right. right, so choose the right tool for the right job and don't be afraid to mix technologies. So in this scenario, we have the traditional EDW working along with Hadoop, Cassandra for web analytics and ad impressions, high volume data, Redis just taking an onslaught of high volume data and being used as a lookup cache and maybe our big data ETL, and Titan, which is being used for different networking type problems.
And that's it.
And that's it.
Yeah. Great.
All right, no Mike's. Mike's from Pennsylvania is going to do a demo. Test.
Try to use the mouse.